13.1 is going to deal with a couple different what are called conic sections. Now, conic sections get its name because some Greek mathematicians thousands of years ago were sitting around and realized, hey, if we take a cone and slice it with a plane, then some of the intersections are interesting shapes. Like one of them is a circle, another one's a parabola. If you incline your plane just a little bit, then you get this oval shape called an ellipse. And last but not least, if you slice your cones parallel to the axis of symmetry, then you're going to get two parabolas that face away from each other called hyperbolas. So lots of different conic sections. The ellipses and hyperbolas we're going to study more in Math 1540, College Algebra, the next course. But right now, let's work on some stuff with the equations of circles. So to start out with, for the equation of a circle, we have to first derive its formula. This is one of the few things I can actually prove to you without too much fuss. Let's say the center of our circle has got coordinates of h and k. Does anyone know what this distance here is called? The distance between the center and a point on the rim or a point on the circle.
Radius?
Yeah, that's your radius. So we'll call that r. This point has coordinates, well, let's just give it general coordinates of x and y. And what's true about the circle is that no matter where you are on the circle, that distance r is going to be the same. So let me fill those numbers in to the distance formula and see what we can come up with. So instead of d, I can write r equals the square root of, I'll plug this in for my x2, y2, and this in for my x1, y1. It's going to be x minus h squared plus y minus k squared. Okay, not so bad, but it's kind of an ugly formula. I mean, it's got this square root in it that we just don't really like. So then what can we do? Well, how about if we get rid of the square root? What process could we go through to get rid of the square root here?
Factoring.
It's not going to factor.
Square root, cancel out both.
So this is, so I could just write this as x minus h squared.
Square both sides.
There you go, square both sides. Unfortunately, you can't just take the square root here. The square root of a sum is not the sum of the square roots. But you can square both sides, and that means on the left-hand side, I'll get an r squared. So this is the equation of a circle. Let's take note of a couple things. First of all, the center of this circle is h and k. So that's the one you want to kind of star in your notes. So the center is at h and k. And even though there's an r squared here, what's the radius? Radius is just going to be r. Remember, we had to square both sides to get rid of the square root, but the radius of this started out as r. It's still r, despite the fact that we squared both sides. We just have a better looking equation to deal with. So, okay. Let's take a look at a problem that you might see in WebAssign. They're going to ask you, for instance, what's the center and what's the radius of this circle? My suggestion to you is that when you're faced with these kinds of problems, that you not necessarily try and put it in the form of x minus h and y minus k, etc. Rather, I would suggest that you just ask yourself, well, what value of x makes the squared term equal to 0? Well, what value of x here would I make? -3. Good. How about for y? 1. And there you go. 2 quick points. How about the radius? Now, a lot of times I get the radius is 81. That's not true. What is the radius?
9. Great.
It's the square root of the right-hand side, so it's 3. Remember, this is really 3 squared, and it's 3, that's your radius. What's saying you?
If you take, how does that work? Because if you square a negative, wouldn't it become a positive?
It will, but where are we squaring a negative?
Like if you square x plus 3, how would you get the opposite?
Well, remember what I'm trying to do here. I'm trying to find the center. So really I want to put it in the form of this equation. So let me go over here, example A. So my equation was x plus 3 squared plus y minus 1 squared equals 9. If I want to put it in this form, then I got to write this with a negative, correct?
Yeah.
So it'd be x minus something and y also minus something equals something squared. So let's see if we can't figure out what those somethings are. Now, adding 3 is the same thing as subtracting what? Negative 3. And then the y that's already in the right spot, y minus 1. And then finally, the right-hand side is your 3 squared. So if you line that up in comparison with our x minus h squared plus y minus k squared equals r squared, that's pretty much telling you all that we need here. H, well, that's what you're subtracting. That's a negative 3. And y, well, the k is 1. And what are you squaring on the right-hand side? Well, our radius is 3. So, you know, we end up with the same conclusion. My suggestion is that when you're looking at this, rather than rewrite it like this, just ask yourself, well, what do I put in here to make that 0? It's just a little faster, maybe a little bit more convenient, but it's up to you. And you could rewrite it like that. Thanks for the question. So let's try one in kind of the opposite direction. This time, for example B, they're giving you your h and k, and of course r, and they're asking for the equation. So that means plugging it into x minus h squared plus y minus k squared equals r squared, and then maybe simplifying it a little bit, not a lot necessarily. So there's a couple forms that I would accept this answer in. H in this case is negative 2, y is 6, and the radius is 12, so 12 squared. I'd probably like this cleaned up a little bit. If you want to leave it as 12 squared, I'm okay with that. But I'm really not a big fan of the negative of negative 2. What do you think I'd prefer here?
Positive 2.
Yeah, positive 2. So probably x plus 2 squared plus y minus 6 squared equals 144. If you want to leave it as 12 squared, that's fine. I'm not going to cry about that. That's okay. Because that makes it a little bit more clear what the radius is for those of you who don't have all these perfect squares memorized. Let's take a look at, well, actually, you know what? We can take a look at the graph of this one. There we go. So if you look at this, there's your center at 3 and 1. You've got a point here at 0 and 1. So you can kind of see that, all right, the distance between these things is 3. Or if I go north and south, I can find some more points. Again, the distance away from the center is 3. So it matches what we expected. Let's come back over to here. Write the equation of a circle in standard form. with the following properties. This time we got a center at 0, 0 and a radius of 1/2. So once again, you've got your H and your K. So let's keep consistent. That's H and K. And then, of course, your radius. This one will actually simplify pretty nicely. Has anyone got it? Does anyone want to just bark out an answer? Jameson.
X squared plus y squared equals 1/4.
Perfect. It starts out as x minus 0 squared plus y minus 0 squared equals 1/2 squared. But x minus 0 is just x. So I'll write that as x squared plus y squared equals 1/2 squared is 1/4. Great. Nice. Thank you, sir. Let's try that one last time for some less than friendly numbers. This time we have 2/3, -7/8, and square root of 2. Again, this is something that I'd want simplified. I hope this is kind of easy stuff. These are easy problems. So there's two things that I would expect simplified on this. Ryan, what do you think I'm going to look for in terms of a final answer? What do you think I'll write on my answer key anyways?
X minus 2/3 squared plus y plus 7/8 squared equals 2.
Perfect. So the two things I'd be looking for is the double negative becomes a positive. Square root of 2 squared is just 2. Nice. Nice. Again, you can kind of look at that on decimals if you want. So we follow along the link. And there you go. There's your center, 2/3, -7/8. So looking pretty good. Tougher to tell that the distance between here and here is square root of 2. You know, you probably have to take out a calculator to see that, but it is. So looking good on that one. How about this next one? This next one looks kind of funny. You're going to be asked to find the center and radius of a circle like this. Does this even look like a circle? It really doesn't. So in order to see this as the circle that it really is, what we're going to have to do is do a little bit of work here. And that's where I've given you kind of a reminder on some of that stuff over here. And the reminder goes back to completing the square. So when you have something like x squared plus 6x equals 5, well, okay. Remember how to complete the square and stuff like this. You take half of 6. Half of 6 gives you what?
3.
3. And then 3 squared gives you 9. And it's that 9 that's going to go right here. If I add 9 to the left-hand side, I also have to have 9, add 9 to the right-hand side. So, okay, that's fine. Well, let's take stock of what we have now. We've got x squared plus 6x plus 9 equals 9 plus 5 is 14. The left-hand side is now a perfect square. It's x plus 3 squared.
Wait, did you say plus 15?
14. Yeah, 5 and 9 is 14. So if I said 15, then I was mistaken. 14. So that's what completing the square is going to look like for that one. Try and refresh yourself on this one. If you're watching this later, maybe pause the video, see if you can't complete the square on this. What am I going to add here for that y squared minus 8y? I have to, of course, add something to both sides.
Negative 16.
Is it a negative 16 or is it a positive 16?
Just actually no positive 16.
Good. So, like the last one, you take half that middle coefficient. Half of negative 8 is negative 4. Negative 4 squared is a positive 16. So it's positive 16 that you're going to add to both sides. On the left-hand side, we're going to be left with y squared minus 8y plus 16. On the right-hand side, you're left with 3 plus 16 is 19. But the reason we added that 16 there was to make this a perfect square. So it's really y minus 4 squared equals 19. So just a little refresher for you on completing the square there. Now the reason for the refresher is it's very timely. We're going to need that right here in working with equations of circles in standard form. I can't tell where this has a center is. I don't know what the radius is. But if I play with this a little bit, I think I can whip it into shape. So let's see, example C. We've got x squared plus y squared plus 8x minus 6y equals negative 24. So what I'm going to do with this is I'm first of all going to move the x's together. X squared plus 8x plus something. I'll figure that out in a minute. Plus y squared minus 6y, again, plus something. So if you follow sports at all, a lot of times somebody will be traded for a player to be named later. This is the number to be named later. What we're going to do is we're going to complete the square here. And then we're also going to complete the square here. Again, if you want to pause the video and try it yourself, great. But to complete the square here, I'm going to take 1/2 of 8 is 4, and 4 squared is 16. So I'm going to add 16 there. But what else do I need to do?
Add it to the left side.
Yeah, you have to add 16 to the right-hand side, because if you add something to the left-hand side, you have to add it to the right-hand side. Let's try that again with this one. Or maybe you can try it. That 9 goes here. Where else?
Plus 9 on the right.
Nice, thank you. Plus 9 on the right-hand side. Now the reason I did all this is to kind of clean it up a little bit. I wanted to put this in standard form. So the left-hand side, that's now a perfect square there with the x's. Likewise with the y's. I've also got a perfect square. And I'll help you out with the right-hand side. 25 plus negative 24 is 1. Gustavo, what do I square to get this? This is a trinomial. What binomial am I going to put here?
X plus 4.
Nice, x plus 4. Ryan, G, how about over here with the y's? What should I square there?
Y minus 3.
Cool, y minus 3. That's looking a little bit more like a circle, right? Lauren, can you tell me the center and radius of that circle?
The center would be -4, 3.
Nice, -4, 3. And how about the radius?
It would be the square root of 1.
Which is 1. Yeah, square root of 1, which is 1. Cool. Now, unfortunately, your calculators aren't as friendly as Desmos in terms of graphing these things, but you can easily check yourself on Desmos. So here's that equation, and let's see if it kind of matches what we expected. Let me put in an extra little point here. Let's see, that's going to be -3, -4, and 1. -4 and 3, my bad. The radius is 1. There we go. But you can kind of tell that the distance from here to here, or north and south, or to the west, it's all going to be 1. So it looks good. It matches our expectations. Nice. Nice. Are you comfortable with that one? That's a good final exam question because it really gets at a lot of things. It shows me you know how to complete the square. That's a good thing. It shows me understand the equation of a circle. So you can find the center and the radius. So I like that one. It's a good problem. So make sure you're comfortable with that one. Now the other part of the lecture here today is to work with parabolas. And let's see. Let's flip over to the back here, take a look at parabolas and see what's going on there. This is a chance to play complete the square again. So this parabola isn't quite in that nice, neat form that sometimes we like. So, it'd be nice if it was in this form. Y equals A times X minus H squared plus K. And it doesn't bother me if A is positive or negative, H is positive or negative, or K is positive or negative, as long as it's in that form. So here's what I'll do with this one. Let's see. I'm going to move the 15 to the other side. So I'll have y minus 15 equals negative x squared minus 2x. To complete the square on something, the coefficient of your squared term has to be 1. Notice that it was 1 here. Notice that it was 1 here. So what I can do is I can factor out just the -1. Be careful not to factor out the GCF. I'm going to factor out a -1 from both of these. X squared. If I factor out a -1, what's left behind? X squared and then what?
Plus 2x.
Plus 2x. Plus something. I'm going to fill that in with a perfect square. What number do I need to put in here in order to complete the square?
1.
1. All right. So, in case you're wondering, half of 2 is 1. 1 squared is also 1. So I'll put a 1 in here. This is where it gets a little tricky. If I put a 1 in here, what do I have to put on the left-hand side to keep it in balance? And the answer is not 1.
2 divided by 2.
Oh, -1.
-1. If you distribute this, I'd get a negative x squared and a negative 2x. That matches what I have up here. But then I'd also get a -1. So I've really subtracted 1. By putting a +1 here, I really subtracted 1 from the right-hand side. So I'll do the same thing on the left-hand side. That's a little tricky, but hopefully you can practice that some. Now the left-hand side, -1 and -15 is -16. On the right-hand side, that negative doesn't disappear, it just stays there. So -1 But I can rewrite the right-hand side. What's the right-hand side going to look like?
X plus 1.
X plus 1, perfect. So x plus 1 squared. And finally, let's move that 16 back to the right-hand side. Y equals negative of x plus 1 squared plus 16. That's what I wanted. That's in a nice, neat form. And I can look at this and tell maybe the vertex. Can anyone else look at this and say, all right, well, this is what the vertex is?
It would be negative 1 and 16.
Negative 1 for x, good. So that's just coming from here. And it's not negative 1 because of the negative out front, it's negative 1 because the negative 1 is what makes the squared term 0. And then your positive 16, spot on, Colby, thank you. So 16. Great. Now you can use either form of this equation to figure out other things like the x-intercepts, the y-intercept, you know, whatever's easiest. As far as the y-intercept, what do you have to do to find the y-intercept of any graph? Not just this one, but any graph. Set x to 0. Yeah, cool, what he said, thank you. So set x equal to 0. Now you've got two different equations that you can set x equal to 0. They're both equivalent. There's this one right here, and there's this one right here. Both of these give you the same graph. Let's take kind of a quick look at that. So here's one equation, and let me zoom out a little bit. Here's the other version of that equation, and notice that the graph lies right on top of it. So there, there. So there's your vertex. Let's see about the y-intercept. Which one of these equations is it easier to plug in x equals 0? I mean, it's personal opinion, but I think
First.
yeah, the first one, right? Because that disappears, you just get 15. So the y-intercept would be 0 and 15. Great. So looking back at the graph, oh, 0 and 15. How about the x-intercepts? What do we got to do to find the x-intercepts?
Set y equal to 0.
Set y equal to 0. All right, so we'll set y equal to 0. Let's do that on our paper. So example D. Zero equals negative x squared minus 2x plus 15. Boy, it's really kind of a pain to have that negative there. So it'd be nice if it was positive. Go ahead, Colby.
Just multiply by negative 1.
Yeah, we're going to multiply both sides by negative 1. Now, being the helpful and kind instructor that I am, I'll do the left-hand side for you. We get a 0. What do we get on the right-hand side, though?
X squared x squared plus 2x minus 15.
Nice. And that factors. Ooh. I should have my Darth Vader Imperial March music queued up.
Yeah, I have negative 3.
5 and negative 3. The larger number has to have this sign. So that gives me two possibilities, negative 5 or positive 3. Let's see how those line up with our graph. Negative 5 and positive 3. Yay, perfect. And there's your y-intercept as well. So it's got all the points that I would want to see. All right. Now you can get a freebie because the line down here at x equal -1, and let me make it a dashed line here. This one. That's your axis of symmetry. So if there's a point right here, there's going to be a point on the opposite side of that line. So -2. There you go. -2 and 15. So a mirror image of it. All right. Let's move down to example D, or E. I'm sure. Yeah, example E here. What's different about example E than, say, some of the graphs you've dealt with before?
It's the inverse.
It's not quite the inverse, but it is different.
Opening to the right instead of like up or down.
Yeah, so you got a parabola in y squared, and if we take kind of a quick look at the graph, it's going to open to the right. Same with this next one. Because it's a parabola in y squared, it opens to the right or to the left as opposed to up and down. Now, our work in finding everything is still going to be pretty much the same. It's just that these last two don't have nice even numbers. But let's see what we can do with them nonetheless. All right, so let me just copy this one down. Example E. X equals 2 times y plus 1 squared minus 3. The first thing to do is to find the vertex. X and y. And to find the vertex, my suggestion is that you start with the squared term. What makes the squared term equal to 0?
-1.
-1 for what variable?
Y.
-1 for y. So if I put in a -1 into this equation, set y equal to -1, let's see what I get for x. I get x equals 2 times y minus -1, or no, plus -1, squared minus 3, which is 2 times 0 squared minus 3, which is just -3. And it seems like, and you'd be right in thinking this, seems like, oh, I could have just read that off of the equation here. The tough thing to keep in mind is that your coordinates go in kind of a weird order. It's -1 for y and -3 for x. How about my y-intercept? Or no, let's just try and find the x-intercept first. X-intercept. What do I have to do to find that? All right, set y equal to 0. So let's set y equal to 0, and let's see.
This is supposed to be -2.
Say again?
On the handout, this is supposed to be -3.
+3 on example E.
I think I changed it up because I wanted to have actual x-intercepts and y-intercepts. So if it's a +3, I wouldn't have a y-intercept. So yeah, let's go. So if it's different on the handout, my bad. But I do mean it for it to be a -3 here. X equals 2 times y plus 0, and actually, rats. Let's try that again. It's going to be x equals 2 times 0 plus 1 squared minus 3. So it's going to be 1 squared is 1 times 2 is 2. 2 minus 3 is -1. So 0 for y gives me -1 for x. 2 down, 2 to go. So the last thing to do is to figure out, well, where does it cross the x-axis? How do you find the y-intercepts? Nice. Set x equal to 0. So let's do that. So that's going to give me a 0 equals 2 times y plus 1 squared minus 3. Now, one of the things you're going to face on the final exam is a series of questions about quadratic equations. This is a good example. And you want to think about how you want to solve these things. You're going to have several different methods. You could factor, you could use a square root property, you could use a quadratic formula. In order to use the quadratic formula here, well, there'd be a little bit of extra work for ourselves. You'd have to write it in the form of ax squared plus bx plus c equals 0, which means you'd have to square this out, which is y plus 1 times y plus 1, FOIL it out, then distribute the 2, then combine like terms and subtract the 3. There's a fair amount of work involved there. But because I've got a nice squared term here, I'm going to approach it differently. I'm going to move the 3 to the other side. When I move that 3 to the other side, what happens to it?
It becomes a positive.
It becomes a positive 3. Divide both sides by 2. 3 divided by 2 is y plus 1 squared. Looking better, although I'm not really fond of that 3/2 on the left-hand side, but not much we can do about it. One last thing to do. Yeah. Take the square root on both sides. Good job, Colby. Except I'm missing something. Nope, not yet. Yeah, need that plus or minus there. There's 2 solutions. You need both of them. Now to finish getting my solutions, I'll move the 1 to the other side, so -1 plus or minus a square root of 3 over 2. Now I gotta confess, if you ask me, you know, what's -1 plus the square root of 3 over 2? I'd shrug, I don't know. You know, eventually you're gonna have to graph these things. So do yourself a favor. Let's look at the roots here. So the positive root is gonna be y equals -1 plus the square root of 3 over 2. And you take out your calculator and you get an approximate value. So what would that look like? Oh, -0.2, positive 0.2, positive 0.2. All right, so -1 plus the square root of 3 divided by 2. Okay. Now, when I look at your graphs, I'm not going to take out a magnifying glass and go, oh, I seen you. Sorry, that was -0.23. Should have been -0.22. I'm not going to look at it that closely. So what you want to do is just give yourself to the nearest tenth, 0.2. And then likewise, -1 minus the square root of 3 over 2 is about -2.2. Quick pro tip for you on getting that second one. If you hit the second key, then the enter key, it'll bring up your previous calculation. Just go back and change it to a subtraction. There's your -2.2. Yep. So, all right, let's put those together up here. Now we got that by setting x equal to 0. So that's these two numbers here. And in one case I got -1 plus the square root of 3 over 2. In the other case I got -1 minus the square root of 3 over 2. And you know, as a favor to yourself, just write approximately 0.2 and approximately negative 2.2. That way when you graph it, that you know roughly where those things are at, and you can draw a decent graph. Fortunately for you, that's already been done. Yay. Right here. So, not so lucky on the next one though. If I ask you what are the x-intercepts, then this isn't the answer that I want. The answer that I want is going to be -1 plus the square root of 3 over 2 and -1 minus the square root of 3 over 2. Those are the exact answers. But you can use the approximate answers to give yourself, you know, a good, you know, where do I graph this? Oh, a little bit past 2. Oh, a little bit past 0. Great. Let's repeat that with this one right here. Let's see, so we've got x equals 3 times y minus 2 squared minus 1. Let's start out the same way, that is figuring out the vertex. So I'll make myself a little chart here. So let's start by figuring out the vertex. Now I need this part to be a little more interactive. I mean, you guys help me out. Colby, go ahead.
So I would set y equal to 0, and then that would be -2 squared, which is 4, and then 12 minus 1.
Okay, we will do that next, because that'll give me the x-intercept. All right?
It's 2 and -1.
Yeah, so if I want the vertex, I'm going to set y equal to 2. So that's my vertex, at least the y coordinate. What's the x coordinate of the vertex? -1. And hopefully you can read that stuff off. If you can't, that's fine. Just remember, always go back to setting the squared term equal to 0. It's going to be 3 times something minus 2 squared minus 1. You're going to plug in that 2. 2 minus 2 is 0, square root of 0 times 3 is 0. 0 minus 1 is -1. Great. So that's our vertex. Let's find the x-intercept. Colby, you're helping out with this one. What do we want to set y equal to? Good, we're going to set y equal to 0. So if I set y equal to 0, well, got a little bit of work to do here. X equals 3 times 0 minus 2 squared minus 1. -2 squared is 4, so it's 3 times 4 minus 1 gives me 11. So y equals 0, x equals 11, 2 down, 2 to go. Now the 2 to go are really where you earn your money on this problem. This is where the lion's share of the points are. This is what helps you get it right. We need to find the y-intercepts. What do I need to do to find the y-intercepts?
Set x equal to 0.
Set x equal to 0. So, all right. So it's going to be 0 equals 3 times y minus 1, or excuse me, y minus 2 squared minus 1. And why don't you give yourself a moment to solve that? If you're here, great. If you're at home watching this later, pause the video and see if you can't come up with the y-intercepts. After you come up with the exact values, then try and come up with a decimal value.
I'm not, but my family has.
So,
Yeah, they went diving up by Black Rocks.
Yeah,
We were
it's
kind
very impressed out. Yeah,
of too cold for me, but.
the past. Oh my God.
Plus,
like, what's
2 plus the square root of 1/3. Should be 1/3. I'm not sure where you're getting.
oh, I just read it.
It should be 1/3. Is that working out okay for you to,
Yeah.
Do the last one. Just- I do the black ones. Find some decimal values.
okay, let's look at finishing this one up. So kind of like the last one, you're gonna move 1 to the other side. You get 1 equals 3 times y minus 2 squared, dividing both sides by 3. And then taking the square root. Do take care that when you take the square root, you get plus or minus the square root there. There's our y minus 2. Let's put in that plus or minus in big, bold pink. If I move the 2 to the other side, it changes sign, so it's going to be 2 plus or minus the square root of 1/3 equals y. Now there's two parts to this. There's 2 plus the square root of 1/3 and 2 minus the square root of 1/3. Both of those are valid values for y-intercepts because the graph's going to cross at 2 places. So we set x equal to 0. 0 and 0. And we got y was 2 plus the square root of 1/3, 2 minus the square root of 1/3. These are exact values. If WebAssign doesn't say approximate your value to the nearest 10th or third decimal place or something like that, it's looking for these things. If it says round your answer to the nearest 10th or something like that, it's going to be looking for the numbers that you get off your calculator. So about 1.4 and 2.6. So about 1.4 and 2.6. You can fill those in on your graph right here. Let's see. Those look pretty good. The exact values are what we asked for. 2 plus the square root of 1/3 and 2 minus the square root of 1/3. Here's your point at 11 and 0. Here's your vertex at negative 1 and 2. There's your vertex. So everything lines up pretty nice. They're a little bit more challenging because they don't work out nice and even like example D does, but that's okay. All right. Let me put this one to rest. Are we okay with those last two examples? All right. I think you've seen a lot of the parabolas before. The only real difference is that you're going to have to come up with some of these things on your own, figure out where to graph these. Unfortunately, your graphing calculator can't graph these things very easily. You can if you get y by itself, but even then you're going to have to do a plus or minus. It's kind of a pain. Desmos is pretty nice. If you've been following along with Desmos, you can take a look at things here and click this circle, this one. There's your graph. And I've kind of manually put in the intercepts here as well. So x-intercept, of course, is 11 and 1, or excuse me, 11 and 0, and then you get your 2 y-intercepts here and your vertex. So it all works out pretty nice. Like I said, it's just not that easy to graph these things on whatchamacallit, on your graphing calculator. Final thoughts? Yes.
So when we have that, the plus and minus for the final one, is it just something, just have to look at the graph so you know which one's actually which? So it's like the 2 minus
Yeah.
going.
Yeah, I mean, let's keep in mind that this was about 2.6, and this is about 1.4. So if you look, this has to be the one that's north of 2.6, and this one has to be the one that's south of, this is the one that's north of 2, this is the one that's south of 2. So yeah, and you can estimate these things even better than I have, or better than I usually do. If you put in, that's a 3, that's a 2. So a little bit north of 2.5. 2.5 is where you're going to find 2.6. A little bit south of, a little bit south of 1.5. Between 1 and 2 is going to be your 1.4. So you can kind of get reasonably close. The only time I get really picky is if somebody would put something like north of 3 or south of 1. That's starting to get noticeably far off that you shouldn't. But one thing to keep in mind when you're graphing these things, if you're off in one regard, then this will look out of kilt. It won't look symmetric. So, I see this happen all the time. People accidentally make a mistake with their decimal, and then they try and draw something like this. You know, this one out here, but then this here. And it doesn't look nice and symmetric. Keep in mind that these parabolas have a line of symmetry. So what's above this and what's below this should be symmetric. And these aren't really symmetric points if you've got a line of symmetry through here. So it is kind of a nice double check of your work that it does look nice and even, like this one or this one. Now, as a last remark here, does anyone know what the equation of these horizontal lines would be?
I equals -1 and y equals 2.
Yeah, no, well, I guess it depends on what order you're giving me, but yeah, y equals -1, because it's the horizontal line through that point, and then y equals 2 is the horizontal line through this point. So, yeah, cool. All right, let's put this one to rest.